How to use MCPs that actually work in production. Let's have a technical deep dive. Let's start with understanding why do most MCP demo work but completely fail in production. Everyone is building MCPs today. GitHub MCP, database MCP, cloud MCP, and on paper they look fantastic. But the moment you put them into production, latency spikes, agents stall, cost explodes, and suddenly your agentic system is just a very expensive workflow. You experience slow LLM responses, tool timeouts, broken agent coordination, and zero observability. The problem isn't MCP itself. The problem is how people build and operate MCPs. Today, I'll show you how we actually run MCPs in production at scale with real infra constraints. Hi, I am Kiran Roy, and I am a solution architect at GoML, helping to build AI solutions. We help teams move from AI prototypes to real reliable production systems. And in this video, I'll walk you through a real-world MCP plus agentic architecture we built for a tech platform. We'll start by understanding what breaks MCPs in production, understand the real agentic MCP architecture, and its impact in the implementation. So let's start with the problem. Most teams wire MCP like this. LLM calls a tool returns the data. That's fine for demos, but in production, MCPs behave like distributed systems. LLM latencies are unpredictable. MCP tools have different SLAs. Now imagine multiple agents each calling multiple MCPs. Without control, everything collapses. There are no retry strategies either. At GoML, we don't start with agents, we start with production constraints. Understand the latency, cost, scale, and failure modes. We then design the MCPs around these realities. Let's deep dive into the architecture. So, this was for a tech platform who wanted to have an AI-powered code quality and resolution recommendation engine. They wanted AI agents to review the code, check quality, perform analysis, and recommend fixes. We didn't use one MCP, we used multiple specialized MCP with each responsible for its domain. We made use of GitHub, Git Actions, Jira Atlas, and SonarQube MCP servers. So let's focus on the agentic layout. We used AutoGen for agentic workflow orchestration. There was a selector agent who was responsible for choosing which agent to be called next, an orchestrator, which was responsible for assigning the task to the agents, a summarizing agent, which was responsible to draft the final response, and multiple domain-specific agents, each connected to their respective MCP tools. Now, some would argue that why didn't we choose to club all the MCP tools under one agent? Sure, it's a good idea if it's a smaller use case. But the fact is, the tools within each of these MCPs are of repetitive nature, which means that, let's say, metric analysis could be present in GitHub as well as SonarQube. Looking at these constraints, we decided to have different agents catering to these different tools, and it was a fantastic idea. While the agentic workflow may be pretty clear, another problem would be if we set all this up in a synchronous format. This is where most systems fail. LLM calls are slow, MCP tools are slower at response. So we introduced a polling mechanism. Every request starts at the inferencing pod. The moment a request comes in, we create a job ID and immediately return it. The message is further queued for asynchronous processing. This request is then picked up by the agentic layer. The agentic layer processes this request asynchronously from the queue, and the agents work, emit partial responses at thought events, and draft the final response on completion. So, what's the basic tech stack? As you may have already understood, we were on AWS infrastructure using EKS for delivering these pods as a service. Each MCPs were hosted on different pods. There was an inference pod, which was responsible for taking the request, generating the job ID, queuing the request, and sending the status update. There was an agentic workflow pod, which comprised all the agents and the pipeline associated. And finally, for data storage, we used MongoDB, CloudWatch for logs, and the SQS queue. So there is no request blocking. Horizontal scaling was ensured via SQS. The clear observability was maintained, and there was better UX under higher latency. By now, you might be pretty clear on how we differentiate. GoML focuses on production-first AI mindset. We understand agent orchestration patterns. We can help with MCP governance strategies. Most platforms just sell agents. We deliver agentic systems that survive production. If your AI workloads are growing, if costs are unpredictable, or if agents keep timing out, this approach is for you. Hope to see you in the next session. And for any demos or any queries, feel free to reach out to us at goml.io. Thank you.